It's the last stretch, so let's be here now. And so thank you very much for the introduction. I'm currently Director of Data at Babbel. I'm also an active blogger. D3M Labs is my blog. I've been in Berlin since I was 19 years old, actually, although I am originally from the United States. And I've worked at a bunch of scale-ups and startups in Berlin. Also, I have some good enterprise experience with Dell, Rolls-Royce, and also with the German Foreign Office, the Auswärtiges Amt, I've also worked with AI and implementing advanced analytics.
So hi, I'm Bala. I work at Bayer as a technical lead and basically working on machine learning engineering, getting the product, like the AI stuff from development to production. So that's basically I do currently. Before I was working at Audi as a data scientist for a couple of years, where I was working on manufacturing, basically how the car has to manufacture, like what is the optimal level. So I was working on that. So complete tech guy, yeah.
Hello, my name is Asma Zgolli. I work at Centa MG. We are a consultant company that specializes in AI, machine learning, and big data, AWS. Before that, I worked in a company called ByteCommerce, an e-commerce use case. And before that, I worked on with NIDs on my PhD in machine learning and big data. It was in France. Yeah,
so really great to have you guys here and all of you. What do you think are the top trends in AI that are relevant to your work?
I will start by answering this. As you know, machine learning and deep learning are the trends that are the most evolving faster in the AI field. In our work, we also use graph databases and knowledge representation as graph. According to Gartner, in 2021, the users of graph databases in data analytics fields was by 10%. By 2025, it will be around 80% of the usage of graph analytics in data analytics applications. Examples of graph data science that we use in our companies are deep graph search, community detection, classification, clustering. All this is possible via the tool called Tiger Graph. This tool, these use cases are relevant in different apps like network and traffic optimization or in healthcare.
Yeah. So basically, I work on two major things. One is like predictive analytics and no-code AI. So which is the current trend we are working on. When, for example, like predictive analytics. So I can take up a previous experience as a use case where. So in the Audi production line, right, so the car's getting produced and the workers assemble multiple parts saying, okay, they assemble the window shield, they assemble the nuts, bolts and screws of a particular car to make the car like production ready and then for the customers. These are done not completely by robots, but still it's done by humans. So when they are doing it, human errors occur. And because of that, when they are doing the quality control check, they have to remove those cars out and then they have to fix this car in separate place. They call it as a rework area. They have to fix it in separate place. They bring it back into the line, do all those stuff. So basically, because of this, they are like losing around like every day they are losing like around like 20 to 30 cars down the line. So if you say a day like 20, then you can add up like months and years. So it will be like a huge number of loss in their production line. Like their capacity is getting low. So through that, we were like creating a predictive model based on the previous data, like a time series data basically, to get the informations and then say, okay, you have have this particular problem. You can grab this particular tool, fix this using this particular tool. You can just fix it on this direction. So the AI gives them an complete steps instructions, give them an understanding. Okay, what is this error, and then how they fix it. So because this knowledge of like fixing is like very limited, because like the people who with like 5 years or 10 years of experience has it, and not everyone is experienced enough. So this is basically a knowledge transfer kind of like predictive analytics, give them an understanding, go. So they are able to like fix, they usually take like 1 hour of like fixing a particular car. Now they take like 5 to 10 minutes. They can just fix it in the line itself and then they can move forward. So that is something like a predictive analytics I was working on, and which is currently we are working on something called no-code AI, basically involving something like puzzle pieces. Each and every model is like defined and designed like a puzzle piece. You have an input and then you have an output. So all the model will take care of, like modeling will be taken care by the model itself. So but you have to define all the hyperparameters, the parameters, like different parameters involved in it. But yeah, it's like a puzzle piece. You just drag and drop all those components. You give the input from the data engineering side, you give the input of the data, and then you get the output, and then you see the model like live very quickly. So it is just make sure that the development goes like very quickly. And so yeah, these are 2 major trends which we are currently working on right now.
Okay, great, thanks. And then I have a question about the biggest challenges for AI. And just me personally, I've been in the scene for 8 years. And I remember 2014, 15, 16, going to all these AI and data meetups and hearing about actually exactly the same use cases as we're talking about today. And then it was like the dream, this big dream, AI is going to change the whole world. And here we are talking about the practicalities of AI with the same use cases. This dream has now become our reality. I won't say nightmare, but it's a reality, and we need to get into the weeds of it all. Just for myself, why is this happening that we're still talking about these big dreams? I see that one of the biggest challenges for AI practitioners is their ability to bridge what they actually do on a day-to-day basis with business. And I know we've talked about this before also in this room. How do we make what we're doing actually understandable and usable to people who are not AI specialists? And that is, for me personally, the biggest challenge that I see.
Yeah. Well, I think this is a great point and a very big, important challenge. I actually worked in the, as I said, in the e-commerce field, and this usability of a big part of e-commerce is recommender systems, and the usability of recommender systems and the feedback we get from recommendation we get on the website is very important for the customer. So from a customer point of view, using tools where they recommend, for example, the size of an item that I'm going to purchase. I find it very, sometimes I'm not sure about which size I have and which size will fit me best. And I think it's important to have this kind of application. And with ByteCommerce, we worked on this fit size recommender system, and we used comments from the retailers' platforms in order to extract information about if the item close is if it's too small, too big, and is a good fit. And we find this kind of solution very important for this usability problem.
Yeah, and one more thing which is like very important one is like which we are like working on is something like an explainable AI. So currently for developers also the AI is something is like a black box. So you give something input, you get something output, and you want to predict something, it gets information out. If you want to do a time series analysis, you get the information out. But like not everyone understands what goes inside a black box. If a developer doesn't understand the customers or the people who work at the, like end product or end customers who's working on this particular product, they don't completely understand what goes into this. Yeah, what happens? What do they do with my data? That's the biggest question everyone asks. Like we have GPDR concerns to like protect our data, but still no one really knows what goes into the data. So and being like working in like a pharmaceutical or like a medical industry where like the data are like very personal, because like we handle like the data of like a disease, or like we handle the gene data to understand like is it a genetic disease, or like we understand like a cancer data, or we like go through like private part like breast cancer data. So to understand all those information, so it is very tricky for them to understand what do we do with the data. So being able to like explain them, saying okay, we take this data, how we utilize the data, like do we anonymize the data, or like do we do some pre-processing on it, do we actually help with the data? So those are the major factors has to be like explained to the people, like that are the things we need to do it, and we are like working on it. People are giving like blogs and giving them, okay, they are right now, like for example, like OpenAI is like coming forward and sharing like as an open source code for all the developers, and then they are also working on giving both pros and cons, saying, okay, what are the like successes they have done with this particular AI model, and they have also given saying, okay, these are the racist comments we are getting, these are the some of the things which is happening with our AI. So we are working on the fixing those things, because AI is something which is like evolving. So it learns from it. It tries to find out the features which human cannot find it. So that is the black box thing which we have to explain them very carefully, and we have to be very open about it when we are dealing with it.
And I have a question, because you're currently working at Bayer. So I'm working at Babbel, and I've worked at in the language space in the ed tech area for a while. And when I'm looking at consumer insights and our users, it's very close to my heart that people who use Babbel or whatever other app I'm working on, that they really get the most out of it. And I'm looking at the user data, but how poorly or well somebody conjugates a German verb has a different sensitivity level than somebody's health. And I would even argue that nothing is more sensitive or private than someone's health.
Yeah, exactly.
How do you guys deal with that?
So just to explain you guys, like I'll take up an example from a previous experience. So before I was working in hospital as a research scientist. So there, when we were working with ICU data, basically the patient goes into ICU, like ECG, EMG, all their like X-rays, what are the blood samples they take, how they like operate with those blood samples. So we consider those data to find out, okay, if this particular patient is good for a surgery or not. So if they are like, what's the risk factor involved? Because there is a statistics involved in it, saying, okay, the person who goes into an operation theater now like dies in the bed like 2 to 3% just because of post-operative complications. That is like, okay, they go for some other surgery and then they pick up something else, some kind of like a disease which is out in the air, like some kind of small things. Because of that, people end up with something else when they come out of the surgery. So due to which it causes like different post complications. So when we are dealing with this kind of data, right? So we work on extensively on data like pre-processing. So this data is like stored in the European region. We don't give the data out. Then we work on saying, okay, this data is working. Has to be anonymized, so that means the user cannot be tracked back to particular like patient or patient ID or something. This starts from collecting the data. That is like, okay, there is like in the ECG, like in the hospital bed, you have like a ECG monitors separated out there. But from there, when we collect the data, there is like a special code allocated for that particular patient, and this has been transferred completely, and this cannot be tracked back to the particular system. So that is something called data anonymization we work with. And then once we move forward into modeling, and then when we model the data, and then when we reach the stage of like deployment, and this deployment happens in the terms of like edge computing. So we don't process the data somewhere and then we cannot like work on something somewhere else, because again, like when we are like going into production, right, so we need an input of like real world data. So the real world data comes in de-anonymized. So we need to like anonymize the data directly on the like real world stage, and then do the more like edge computing there near the patient itself, and then give them a result saying, okay, are you good for a particular surgery? If yes, okay, you can go forward. This is your risk score. No, you are not good, like because this score is like high. You have to consider other options before like going into the surgery. So yeah, those are the major consideration we'll take up when we are doing those things.
I also dealt with sensitive data before in a previous experience in NADs and smart grids data. So what we do is use on-premise solution for this data lake. And we also use cloud solutions, but after you are doing this anonymization step. The last challenge I want to talk about in facing artificial intelligence is actually getting the data. Sometimes the data is not always available for this kind of application, or is too small, like other talks we saw during this conference. That is also an aspect of having quality data quality, which necessitates, needs an effort in order to put in place a data management system and data management application in order to solve problems like access rules, privacy issues, have constraints on the data, solve data duplication problems, missing values, and many of these problems that need proper data governance and metadata management.
Okay, great, thanks. So now that we've talked about the challenges, what are some solutions that you're seeing in your work or in the market in general that are really that are making life easier for those who are creating AI?
Okay, according to me, the main solutions that are making it easier for users and developers to jumpstart in the field are transfer learning models, which are very relevant in the field of computer visions or natural language processing. Also, other solutions that are relevant to the field is cloud solutions, which enables the end user, the developer, the student to jumpstart on the field while he doesn't have a super powerful computer. He just uses cloud solution in order to develop his proof of concept algorithm or to deploy his algorithm. Also, cloud solutions offer the opportunity to have automatic machine learning models, which is, according to me, the future of machine learning. Maybe Bala can follow up on this.
Yeah, like there are two things when you said like cloud solutions and AutoML. That is the one which creates the machine learning model on its own. So yeah, cloud solution is something which like everyone is using, at least like we are using. So where getting the development into production, that is like getting the users use the at scale. So when we are like scaling it up, we need like more firepower, and when we are like, and the data, it's all like the quality, the amount of data, not the big data I'm talking about, the amount of data is like huge, like it's in terabytes and terabytes of data. So the processing needed for that particular users, and then there are multiple people working on that particular project. It's not like one guy working on like one project. It's like multiple people, like multiple data scientists working on creating one particular model, doing the feature extractions, data processing, data engineering, all those things happens. So there is another thing called ML ops basically. So we use something called ML flow to do that. So ML ops basically involves in saying getting the information, getting the model out into production and using different level of criteria, like for example dev, QA, and prod, and the users can test out something in the development like without like stepping down from without taking down a particular website or something from the production. So this is particularly happens in ML ops, and we track the model and then we monitor the model, because the model which we are working on all sensitive data. So that means that we cannot we have to be on point with respect to how much a particular model can predict on the accuracy level, and is there any drift in the particular model. So all those things has to be taken care, and these are handled with ML ops. And when it comes to cloud architecture, we are currently using multi clouds. So to have hybrid cloud ecosystem, some are good in Azure, they have Databricks involved in it, and we have AWS, who is good with all the storage power S3 bucket, ECS, and EQS, and all those things. So we take the best out of different worlds, get the user connect to it to make sure okay, we gave the model best solution out of it. So these are the major solutions available, but are these solutions available to everyone? That is a different discussions, because this comes with a price basically. So when we talk about cloud, right, so the amount of money involved in getting a particular model out is completely different from for a corporate to a particular a freelancer guy, or for a data scientist who's working on his own. So is it available? Yes, but is it available for everyone? But that's a separate discussion we have to.
So if we could stick to cloud computing, how a corporation such as Bayer or other larger corporations actually use it. I find this really interesting, how you could actually run ML ops and also using powered by cloud computing across borders with the data that you actually have available. So how does that work in an organization such as yours with A, multinational scope, and B, very sensitive data?
Yeah. So like, as I said, we work with multiple clouds, like we have like MLflow working with it, and then we have, say, like basically like we work as a developer, we work as a agile method. So that means like, okay, if you go do something, you need to like test it out in the real world to make sure that we don't like wait for the perfection. Okay. Yeah. You do something and then you go out and then test it out in the real world. So to do this, like we use like Git, like GitLab or GitHub or any other services which we have, and then Cloud Solutions is another one, and then MLflow is the other one. So there's like a pipeline going around, say, okay, a data scientist data engineer comes in and then has a database in the Snowflake, and then he extracts the data and then say, okay, this is how like the features I need for a data scientist. So he gets all those data and then he make sure that data is like anonymized and all the data is like ready for the machine learning model. So this pipeline goes into the model directly, and the data scientist starts working on it with the like his own laptop or like on the cloud as a ECS instance or something like that.
I have a question. Could actually, when you're in this environment and you're running models across countries, maybe do these models actually can you actually run a model across national borders, or is this something where you have to be very, let's say, cognizant of those legal boundaries when you're actually formulating your use cases?
More than legal boundaries, so we are like when we are developing for cross-country or cross-nationals, so we develop model for particular region or particular country alone. So we don't like have a global model. Yeah, there are some use cases where we have global model, but most of the model are specific to country, because when we are dealing with human, right? So people in, let's say, like for example, like India reacts differently to particular picture, and then like in German we like react to a particular picture differently, but the reaction for them is the same. So we need to like consider different user groups differently, have like a multiple model running for multiple country brands, and again this will change for each and every brand we deal with. It's not like we'll have like single model for each one single brand. So multiple brands, multiple portfolios, multiple therapeutic areas, multiple countries. So each and everything will like go into a niche of like developing the model to get the like good result, because we cannot generalize all these systems, right?
Yep. Yeah.
Okay. So then I have another question about ML ops, if we could go back to that. And this was a really hugely discussed topic during this whole conference. I've been just through my work with startups and scale-ups in mostly Berlin area, but also in New York, I've come to the conclusion that a lot of the startups work in ML ops level 0. If you take Google's scale, some of them have gotten up to ML ops level 1. Maybe there's a couple up to level 2. So I know that some of the enterprise, in the enterprise area, that might go people might start at level 0 and get up to level 2, maybe a bit easier. But what have you seen in your experience? What can people actually reach, or what do people actually reach when it comes to reality and not, looking at the definitions of what the different levels are?
Yeah, when we talk about startups, right, it is more of like people going into the market and they are like scaling it up with like a couple of guys involved. And it's not like 4 or 5 people or like 10 people working on a single model. It's like one guy working on like starting from data engineering to data science and machine learning. So it is like a one job description who works on it. But when it comes to like bigger organization like Google or Microsoft or Bayer or any bigger organization, so they have like specific guy working on niche products basically. Mm-hmm. So that is something we do it, and ML ops is something which is like necessary. So going forward with like moving up the like ladder, right? That is like down the line, like 5 years or 6 years. So there like new roles will come up. So ML ops is one thing. Now data security, that is something which is like coming up, data sec. So those are like new options which will be coming up. Yeah. So as I was mentioning again before, like so this getting the model out from development to scaling it up to user level. So it needs like a pipeline, or else like there will be like a lot of breakage and we cannot track back the system easily. So like we are not developing any like a software for it right now, but we are just using the ones which is available directly. For example, which I gave like ML flow, like from the Databricks basically. Yeah.
So then I have a question now about opportunities. I feel that the last decade was quite a good decade for the economy and also for the tech industry. We had really wonderful conditions, to put it mildly, but now we're living in challenging times, and challenging across multiple parameters of what challenging could be. How do you think that this presents an opportunity for AI, and how do you think that AI presents an opportunity for us as human beings?
According to me, big data brings lots of opportunity to AI. I have worked with energy sector, and our new client is also in the energy sector. I know smart grids, and in smart grids, data is collected and is communicated between the end user and the data center two ways. So the network sends data and electricity, and it collects the data. And every 5 minutes, it collects around 96 million measure. This smart grid that I worked with in France. So it's a huge amount of data, and there's lots of use cases to this energy big data and machine learning, ranging from demand forecast. It's important to predict for the customer how much energy he's using, in order to know his bill, how will it be, especially in this current situation that we are living with the energy crisis. It's very relevant AI application. There's also other application like predictive maintenance and fraud detection. Another use case we are working on in the energy sector with Centa MG is detecting accidents in the equipments for the customers. So for example, we have a big retail customer, and they have like their energy equipments, and predicting that this from the energy data collected, this equipment will fail in the future, will allow the user to be the client to be proactive, and have lots of savings on the energy costs. Also, there's the current situation. We see that AI helped a lot in the COVID crisis in the health department. In my experience also with e-commerce, we saw lots of opportunity from users that with the COVID-19, they don't go to the in-place shops, and they use lots of online platform to purchase their clothes. This is a good opportunity for AI to do these recommender system and other kind of machine learning applications. Also, we're also working in Centa MG on social media data analysis for marketing, and in this project there's lots of opportunity in identifying the clients from social media data, like the segmentation from the behavior that we have from social that we conclude from the social media data. We can divide the client profile and use this in the marketing field. And finally, there's also the customer support application that use AI, and I suppose conversational AI, but I'm not this subject. Okay, so what can you say more?
Yeah, like when we start with like opportunities or like current what is going on with respect to AI, right? So AI is like we are using AI like every day in our lives, starting with the phone where we use like we have like the Siri or like we have the OK Google, which is like basically a natural language processing application, which is like working on it. And when we are like go with like marketing or like when we are looking at the like Instagram post, like we tend to get more in like like more information which is like we like it more. So basically based on the behavior patterns which we can get, they get the information and then they try to suggest you with more information which is like more engaging for you exactly. And like as she mentioned, like so for example like fraud detection, which is like working on like credit card sectors or like financial instruments. And we have like more explicit AI, which is working on healthcare industry, where like people are like trying to find out like drug using like AI, like drug analysis, finding like new amino acids and stuff like that. And we have information going around with respect to disease detection, like early stage cancer basically. So where human eye cannot like capture some of the things. For example, like there's a spot in a finger or something which can lead to something else, but human eye cannot like process it that easily because the amount of data we get is like completely less. So where AI can come jump in, and then there like people are working on it on those aspects as well on a larger scale. Yeah.
Okay, good. So if I could summarize the very high level, AI is working with us, humans, with our human intelligence very symbiotically to get a better solution. So we have to put less effort in to get more out of whatever we want to do.
Yeah, exactly.
Yeah.